Okay, this is a video to run through on another software called Ring, which is a operating system simulator on how processes function, how the CPU handles processes and parents, children, forks, etc. Here's how you run it. Just Google Ring and you'll find it. It's free from, I believe, a college made it. And you unzip it, and here is, it's a batch file, so it runs, looks like off a DOS prompt. Here it goes. You have to allow it. And there's the DOS stuff I was talking about. Okay, and here's the Ring software. Make sure it's recording. Okay, this is the initial process. I've got it default to 10. Number of processes is set to 10. If you want to show more information than just this display, here's output. You'll see what that shows in a minute. A Gantt chart, that's really cool. Set that over here. This is on Windows 7, I believe. Okay, and one more is the variables. Alright, here we go. I'm going to move this over here. Move this down. Move this up. Alright. Minimize that. Okay. That's about all you need right there. Okay, I'm going to just go ahead and run this until it's done. You want to watch this Gantt chart. It's going to show the processes, the process scheduling based on the settings that we have here. And there's a lot of settings. Do all kind of stuff. Okay, run until done. You'll watch this parent fork the processes, the child processes, a copy of itself basically, each one of them. And here it goes. And here's the Gantt chart. I'm going to widen it a little because that's a lot of processes. Oops. We will run that again. Okay, so we'll rerun this. Reset right here. We'll reset everything to where it was originally, except you have to clear some of these sometimes. Okay, run until done one more time. Watch the Gantt. Parent, child. Red is ready but not running. Green is running. So as you'll see, oops. Okay, all the parent forked all these child processes one at a time. That's not concurrently. That's consecutively. And okay, so here's the parent process. This it forked this child process. It created it, but it was ready, but it wasn't running until this parent process completed, as you can see right here. And each process has to complete before the next forked process can begin processing, running. Alright, and it starts at 0. This is the first process. 9 is the 10th process, since we're starting at 0, right? Okay, and it shows the 100 parent 1. I don't know if you can read that. 101 with parent 1, 102 with parent 1, okay. And this is the number of processes. This is a child process. That's about all that shows, not much. Okay. And another thing they said to show was to change this atomic means there's no interrupts that this program, these fork processes were able to run at 100% with 100% of the processor. It's a simulator, so it can do that. In real life, they said this is supposed to be about 20%. Watch me count down on this. I'm going to put it right at 20. Alright. And okay. Alright, and I guess that's all you do. I'm going to reset, and it says not atomic, right? And then this is going to be cool. Watch this. And I might need to move this down, make this bigger because it's going to get weird. Run until done. Ready? And watch the GANTT. So this is with a 20% interrupt rate, which is about what you get on a normal processor. And black means it's a zombie process. And that's it. Okay. Everything else worked pretty good. The output on this was also skewed because of that not having atomic printing. Okay. The other one they said to show was, I'm going to hit reset. I'm going to hit clear on this. Okay. Break child is another one. Ready? And you want to watch this. This is going to be a little different the way this is set up. It's holding all these processes until it's finished. The threads. And it completes them at the end. That's pretty neat. That's about it. Again, you want to notice when the process is created, when it's ready to run, and then when it actually runs. And then it gets put in it's not a semaphore block, but a ready state, but not running, not processing until it's green. Red means it's ready but not running, and green means it's running. It's all over the place. Okay, let's try atomic again. And this is for operating systems class at A&M. A little different, maybe. No, it's the same as the first one. Break child. Let's see, it's running atomic and breaking at the child. Nope. Break child, I said. Break child. Try it again. Okay. There we go. Now you can see that all the processes are ready, but none of them are running. Because the parent is having to create all of the processes at one, it's creating all the processes at not at the same time, but consecutively, and it's not finishing its processing until all of the fork processes are created. Once those are created, then it completes, and then each fork process runs consecutively, as you can see here. It's pretty cool. All right, y'all have a good one.